Welcome to the video lesson on properties of logarithms. You've been working with basic introduction to logarithms over the last couple sections, and so now let's look at how we can use that basic intro to actually dive a little deeper into some properties that involve logarithms. So if we're looking here, if we have log base 2 of 5, that's the way we write it, log base 2 of 5. Now if we have log base 10 of 5, well, it can be written as just log of 5. So if you do not see a number after log, you will assume that the base is 10. And then remember, from using natural logarithms, log base e of 5 is just going to be the natural log of 5. So just remember that log base e changes to ln. So that was just a quick recap. And basically, when you have log base 3 of 3, log base 4 of 4, log base x of x, those are all going to be equal to 1 because everything I have circled is going to be the same there. Now remember, natural log of e is just log base e and then of e. And of course, that'll also equal 1 because those e's are the same. And then log base 10, we just talked on the last slide. If you don't see a number here, you'll assume that there's a 10 there. And then since those are the same, you'll get a 1. And remember, going back to our very basic intro there to logarithms, we take this number here, the base, we raise it to this number, and then that should give us that number. Right? Basically makes sense. But if you see it as log base 8 of 8, you don't want to go, well, 8 to what power is equal to 8? You don't want to have to do this. Just recognize those are the same. It's equal to 1. Saves you a little bit of time. The first property of logarithms is the product property. And that says if we have log base b of u times v, that's just going to be log base b of u plus log base b of v. And if you look down here in the example, log base 8 of 20, well, we have log base 8, 5 times 4 is equal to 20. And so we will add those two logs, log base 8 of 5 plus log base 8 of 4. That is equal to log base 8 of 20. Now there's also another one down here, because you could use 10 and 2 to multiply to get 20. And so we could use the product properties separated like that. It does work with natural logs also. The natural log of 80 is equal to the natural log of 8 plus the natural log of 10. Or we could say the natural log of 16 plus the natural log of 5. And of course, there's plenty of other ones that we could choose. It'll be situational in how you break it down. Oh, now we're going to be looking at the quotient property. The quotient property just says if I have log base b of a fraction, I'm going to take log base b of the numerator, and I'm going to subtract log base b of the denominator. And you can look here at the example. Log base 4, both of these are log base 4. 3 is the numerator, so it goes first. 7 is the denominator, so it'll go second, and we are going to be subtracting those common logarithms. And as you probably guessed, it works with natural logs also. Now the power property, so if we have log base b of u to the n power, what you will do is you'll just take the power n and it goes out in front of your your logarithm to get n times log base b of u. So in the example, log base 6 of 81, well, 81 breaks down into 3 to the 4th power. And then so I've just changed 81 to 3 to the 4th power. And since 4 is now the exponent, it'll come out in front. So we have 4 times log base 6 of 3. Log base 6 of 3 with the exponent in the front. And there we go. Works with natural logs also. Natural log of 100 is equal to the natural log of 10 squared, which is equal to 2 times the natural log of 10. All right, here are some examples. I'd like you to try these. If you feel comfortable doing these on your own, then work them out on your own, and then hit play and make sure they match up with mine. If you would like to work along with me, let's go ahead and do that. All right, so first off, I'm seeing this. We basically want to just manipulate these. We want to change these to hopefully to be something simpler. So if I have this here, the exponent, remember, if I have a log, and remember there's no base, so we know that's a 10. So if I have log with the fraction 7/9 raised to the 2nd power, I can take that exponent and strip it out front to become 2 log 7/9. And now remember, I'm going to use my quotient property and split those up. So here's my 2. So I'm splitting it up log of 7. And the quotient property says I'm supposed to subtract log of 9. And so that's one way to manipulate. Now you might say, right here, isn't 9, isn't that 3 squared? So let me go ahead and erase that, and let me put 3 squared there. Now what am I going to do with this exponent of 2? It goes right in front of that log. And I kind of forgot something. When I go from this step to the next step, this 2 is outside of all of this. So I should go ahead and make it outside of all of this. And therefore, my final answer, I'm going to have 2 times the log of 7 minus 2 times the log of 3. Because this 2 comes in front of that log of 3. And so that's kind of a, I don't know, a different way to look at this. Now, since these are base of 10s, you could type that into, you could have typed it into the calculator at the very beginning, but I'm showing you how you can manipulate this to get something different, because we're going to be using different bases here soon. So I guess that's one method of manipulating it. Let's look at the next one. So if we have this, how can we manipulate this? Okay, so if we're looking here, I see an exponent of 4, but remember, that exponent of 4 is only outside of this parentheses. It is not outside of the whole thing. All right, so first off, I'm probably going to look at the quotient property. The quotient property says I'm going to have log base of 8, and then I'm going to have 5x plus 4, nope, 5x plus 3 raised to the 4th power. Quotient property says I'm supposed to subtract the log base of 8 with the denominator. Okay, so now this 4 is outside of everything that we have log base of 8. So the 4 will go out front. 4 log base of 8, 5x plus 3. Then we have minus. And now if you look here, 4x squared, I know 4 is 2 squared. So if I have 2 squared x squared, won't that just become 2x squared because everything inside the parentheses was raised to the second power. There we go. And so now we take this exponent and ship it out front. 2 log base of 8 of 2x. And there we go. That's about all those further we can go with this. We're just showing you how to use all three of those properties together to get something that looks a little bit different. In this one here, well, it looks like we are multiplying two numbers, multiplying them. So let's use the product property. The product property is going to tell us that we're going to take the log base 6 of the first number, and we're going to add it with log base 6 of the second number. So log base 6 of the first number plus log base 6 of the second number. No exponents to deal with. That's pretty much all the further we're going to go with that one. And now, what can we do to simplify this here? Let's simplify this a little bit. We know it's a product property, so we're going to have log base a of the first number, x squared plus 1 raised to the 4th power, and we're going to add it to log base a of the second number. Well, we can ship this to the front. To get 4 log base a x squared plus 1. And then, what is the square root of x? Isn't the square root of x also x to the 1/2 power? So what I'm going to do then is I'm just going to put x to the 1/2 power here. And I just stuck it in parentheses because I wanted to make sure that the 1/2 power was stuck with the x, but I guess I don't need it inside the parentheses because I wanted to show you that we could bring the 1/2 out front. To get 1/2 log of a to x. And so as we look there, okay, sorry about that pause there, but if we look here, there's not much else we can do. We cannot really go any further than this. So now I want you to try this. Say we have log base a of 5, and we're going to add log base a of x, and then we're going to subtract log base a of 2. I'd like you to turn that into a logarithm. And so if we think there, since they all have the same base, that kind of helps us out. Since they all have the same base, let's look at the first two. They have the same base, and we're adding those two logarithms. So isn't that the product property? Log base a, and then we take 5 and multiply it by x to get 5x. And now if we look here, log base A of 2, well, we're subtracting. I believe that's the quotient property. They have the same base. So we're going to say log base A, the quotient property gives me a fraction bar. 5x will go on top, 2 goes on bottom. And so we have changed what we started with to one logarithm there. Okay, and your last property is the change of base formula. This change of base formula is going to be real helpful in you doing some calculations. So remember, we want to let u, b, and c be positive, and we want b and c to not be 1. So if we look here, this says log base c of u is equal to log base b of u divided by log base b of c. So basically, we take what we have started with, split it up, and we have the log with the same base, and we can pick whatever that base is going to be. Ideally, it's naturally, or it's not naturally, it's going to be easy if we make that base to be 10, because there we can quickly type it into the calculator and find an answer if we need to. So they're going to have the same base, and then u goes with the log on top, and c goes with the log on bottom. And so in our example, log base 8 of 5, well, I chose log base 10, and remember the 10's invisible, so I chose log base 10 for both the top and the bottom. The 5 goes on top, the 8 goes on bottom. And so if I'm going to need a number for this, I come to the calculator and I say log base 5's on top. So we'll say log base 5. Now I have to close my parentheses, divided by log base 8. And I can hit enter, and I get an approximation, and I get a decimal. That's if you need to. So that's the change of base formula. This is a way to go with something like this and to be able to use a calculator to quickly come up with a decimal or an approximation. Plus it's something that we'll be using in situations that involve more than just numbers here. It'll involve some variables. So if we look, how do we change log base 4 of 5? Well, I could go like log base 8, and then the 5 goes on top, and then log base 8 with the 4 on bottom. That is equal there. But remember, log base 8 doesn't happen in the calculator. So if we just say log base 10 of 5 and log base 10 of 4, that's what it looks like. So you can type that into the calculator and figure it out. Let's see if you can come up with the rest of these on your own and hit play when you're finished. So we're going to say log base 15 over log base 7. Go ahead and hit pause here. Play when you're finished, and then see if your solutions match ours. All right, so if we have log base 8, you might be thinking, oh, I want to go log base 8 over log base 10. But then if we have log base, I'm sorry, I said that wrong. If we have log of 8 on top, and then we have log base 10 of 10 on bottom, wasn't that just equal to 1 on bottom? And then that gives us back to log base 8. So don't get caught up and think you have to do all of this extra work right here. It's already something you can type into the calculator. Log base 10 of 8, or just log of 8, type that into the calculator. And then the bottom example here, we're going to just say log of 9 divided by the log of 5. Type that in your calculator, you got it. And this one here, let's try to do some simplifying. Let's look at the top. I guess the top we're going to say log 5x plus 3 divided by log of 4. Not much further you can not much further that you can do with that. Down here in the example at the bottom, we're going to say log (27x cubed) is on top, and then log 3 is on bottom, right? Okay. Now, what about 27x cubed? 27x cubed. Isn't 27 equal to 3 cubed? And since both of them are raised to the third power, couldn't we do this? Okay. So let me go ahead and do that. So where are we at? 3x cubed. Okay. And so now from here, this 3 will go out front. So we have 3 log 3x divided by log of 3. Okay, since 3 is on top of a fraction, you want to remember how to use fractions. We're just going to bump it out to the side of the fraction bar. So we're going to have 3. And isn't this the product property? So that's going to be 3. And then on top, we're going to have the log of 3 plus the log of x. And then on bottom, we have the log of 3. And then you should recognize, so we have the 3 there. We want to split up this fraction. So we want to put the log of 3 underneath the log of 3 and the log of x. So that's going to look like this. We're going to put it in parentheses here. So we have the log of 3 over the log of 3. Here's our plus sign, plus the log of x divided by the log of 3. And you should recognize that this cancels. Cancels down to 1. And so, where do we go? We can just say 3, 1 plus log of x over the log of 3. So there you go. One way to manipulate it to get it to go from the log base 3 of 27x cubed down to here, to go from the start to something else. Okay, I believe that's all we have for you. Let me know if you have some questions and I will get those answered.